We're going to be looking at functions and their properties. There's a lot of information to cover, so we're going to cover this in 2 days. So this is going to be Functions 101, and then the next video that you watch will be Functions 102, just to kind of make sure that we have our differentiation there. Before we get into functions, we need to talk about domain and range. So the domain are the x values, range are the y values. We're going to look at a graph in a little bit, so I'm going to explain that one a little bit further, but that should be a review of domain and range. Regardless, like I said, we'll look at it in a different light with an actual graph. Now, a function. A function exists where there are no repeats in the domain. So this is going to have to pass the vertical line test. And we've talked about the vertical line test before, so this probably is just a review, a little bit of a refresher. So let's look at an actual graph here. All right, I have a graph here. It's an x cubed graph. Just kind of rough sketch it in your notebooks, that's fine. So the first thing I want to do is I want to make sure that this is in fact a function. Does it pass the vertical line test? So remember, the vertical line test is, if I were to draw a bunch of vertical lines, is there any spot in which that graph, that red graph, is going to touch my vertical line more than once? So if I look at this, it only touches it once, and I could just keep going, and that's how I'm going to determine whether or not it passes that vertical line test. In this case, it does pass the vertical line test, therefore this is a function. Now, let's talk about domain and range and some of the characteristics that are on this graph specifically. Domain, we said, are the x values. So remember, I like to kind of give me to the edge of the graph. How far left, this is left and right, so how far left does this go on my graph? Well, I can see here, this just keeps going on forever and ever. So that's going to be negative infinity, because it's just going to keep going to the left. If I look at the right side, again, it just keeps going, so it's going to go all the way to the right side, so that's a positive infinity. Just a reminder, we're going to use parentheses when it's not included, or an infinity sign, and we'll use brackets when it is included. So now, looking at the range. The range, actually I should do that in a different color. The range are the y values. So same concept, I go all the way to the bottom of my graph, to the top of the graph. Well, I can see here, again, it's still going on forever and ever. So that's negative infinity. Look at the upper bound. Again, still going on forever and ever, so that's positive infinity. So my range, negative infinity to infinity. We'll look at a couple more graphs when we're actually in person, so you might get a better idea of what we should be looking for there. So domain and range, domain left and right, range up and down. A function has to pass the vertical line test. Now, there are some times where you might have some issues with your domain and your range. You might have asymptotes. You could have either horizontal, actually let's do this as a subcategory, or you could have vertical. So a horizontal asymptote, this is where your graph is going to approach a limit of plus or minus infinity. So the limit of x as it approaches plus or minus negative infinity of f of x equals some number. We'll just call it b in this case. Okay, so that number, most of the time when we're looking at a graph, most of the time it will be 0. Vertical asymptote. This is where your limit, as it's approaching a certain value from the left and the right, is approaching negative infinity or positive infinity. Okay, that's a lot of jargon, right? A lot of math jargon. Have a refresher here on limit notation. But let's look at an actual graph. This is going to make it easier for us. Let's get rid of this though. So we can look at a different graph and have a better idea of what we're actually looking at. I'll erase that when I get it back up there. So let's say my function, if I type it in correctly, is, oh, I don't know, let's go x divided by x plus 3. All right, so there's my graph. I'm going to erase that information, and I'm also going to get rid of that red graph so it's a little bit easier to talk about. So go back to leave that up there. Okay, we got a graph here. Zoom out a little bit here. So looking at this, I have, like I said, some issues, aka asymptotes. If I look here, I have an asymptote line here. General broad term is an asymptote is where the graph is never going to cross. Okay, but that's not technically the true definition of it. The true definition is using that limit notation. So if you notice here, we have a horizontal asymptote line here. Okay, now looking at this based on my graph, I can see that the horizontal asymptote line is at y equals 1. Okay, you just look for it, figure it out. Now this one, I have a vertical asymptote line. Vertical asymptotes, you can figure those out without a graph. In this sense, because we're dealing with a reciprocal function, it's wherever the graph cannot equal a number. If I'm actually looking at what the function said, if I look at that x plus 3, I know it can't equal -3 because I can't divide by 0. So easy to figure this one out without a graph. So the vertical asymptote here is at x equals -3. So that's our vertical versus horizontal asymptote. Those are things that you just need to look at in order to figure that out. Now, this leads into discontinuous functions. And there are several different classifications for discontinuous functions. Okay, discontinuous functions. One of the easiest ones that we just looked at is where you have a infinite discontinuity. Because I don't have anything possible there. Okay, that's probably the easiest one there is. We also have a removable, sometimes known as a hole. This is where I'm going to have something like this. Maybe a little bit better of a picture, but you're going to have a removable or a hole because that graph just keeps going, and then all of a sudden, boom, I can't have it exist there. The next one, and there are a removable or hole. This one's more specific because you actually can see the hole. There is another type of removable. Actually, let's not make that a straight line. So you can see we're going to have 3 different types. There is also a removable that could look like this. Notice the green one here, I don't have another value. It just is gone at that spot. But on the blue, I have it where there's a hole, but there's also another value in a different location. And the last one is a jump. With a jump, you're going to have some type of graph, go to some point, and then it literally jumps the graph to a new location. But notice it's still continuing, so those 2 points are not connected, therefore it cannot be a removable or a whole. It just literally jumps from point to point. So you'll be looking at and working with the graphs of this. Later on, we'll be talking about how you could find those using limits specifically and whether that point actually exists. But for now, these are functions in a nutshell, and we will go a little bit further in depth in the second video.